All right. Um, so in this session, we're gonna see how we can populate those match action tables, and this is happening at runtime. It means that we compile the program, we deploy that program on the switch, and then at runtime we decide what are the table entries that we want to insert in those tables. We talked a little bit about it in the previous presentation. Whenever we have a match action table and it has the match key and the action data, they come empty by default. So you create a table that has no entries at all. And it's the job of the control plane to decide what are those entries that will be filled here in the table. And the control plane has more than just inserting the entries. So you can remove, you can update, and you can even configure some elements in the P4 switch that are also related to other advanced topics such as multicasting and other stuff as well. But here we are seeing that we are just seeing how we can insert a certain entry in the table. And basically, when we do so, we have to specify which table we want to insert the entry to, because remember that potentially you might have multiple tables in your program. And then for that table, you want to specify the action and the match key value. So for example, here we are saying for IP forwarding, IP4 forwarding table. So that's the table name. For the action, IP forward. And the key here is 192.168.0.1. And then the action parameter here, which is 4, right? And this corresponds to the action data, the egress port. Now, for the BMV2 switch, which is using the simple switch target, there's a tool called simple switch CLI that we use to populate the tables here in this lab series. And this tool includes a program independent CLI. And this means that the available functions to be used inside this command line interface are not depending on what you write in the program. For example, if you have something like table add, it's just accept the table name as part of its parameters, right? So, but it's not like table add and your table name all within one function. This is what we mean here by the program independence. And if you look at this diagram here, we see that in the data plane at the bottom, we have simple switch, which is the target of BMV2. And in that switch, we have a program independent control server. So there's a server that is running there. And then from the control plane side, we have the same thing, but it's a client. And this client will connect to the control server and basically call these APIs to manipulate the tables. Now, the connection between these two is through Thrift here, which is based on TCP sockets. And there are other ways to actually have this control plane, data plane communication. For example, you might have heard of something called P4 runtime, for example. But here we are just sticking to the most simple way, which is through like this Thrift communication. And we are assuming that we are doing things locally on the switch. So the switch will have the data plane and we will use the control plane on that same switch. So for this lab, we're going to be using the same topology as the one that we used in the previous one. So 1 switch and 3 hosts. So for this lab, there won't be any P4 programming. So we will assume that the P4 code is already written, right? All we have to do is just compile it, push it to the switch, and from there navigate this tool, which is used to populate the tables at runtime. But we will not do any P4 programming. And we will see some features such as displaying the ports, tables, actions, and how we can insert, update, and remove the table entries. Okay, so I will shift now to the platform. I already made the reservation, so this is lab number 7. Okay, it's called populating and managing match action tables at runtime. All right, so we're gonna be doing the same thing as we did, same structure for the lab, right? I'll start with the theory. Here in this specific lab, we are discussing how the runtime works. So what is Thrift, gRPC, those kind of protocols that are used for the communication between the control plane and the data plane. Okay, and we are emphasizing that we're going to be using the simple switch CLI to manage those tables at runtime. So from section 2, we will start first by opening mini edit, which we will find a shortcut on the desktop. And there we're going to type in password as the password. So again, we're going to be using the pre-built topology. This is going to be the one related to lab 7. So all we have to do is file, open lab 7 and lab7.mn. So now we have the topology here. The next step is to, of course, run that topology by clicking on the run button. So before we proceed, I just want to re-emphasize that you are free to build any topology that you want. So you can potentially have multiple P4 switches. For this lab series, we just started very slowly, very basic. We are just using one switch. But you might want to, let's say later on, if you are exploring advanced topics and you want to see how subsequent switches are modifying the packet, you can just click and drag at those switches. And another point here is that beside the P4 switches, you can drag legacy switches. And also you can use routers which run FRR. So you can really deploy a complex topology here for research and basically try to experiment with it. And one other point is that this whole VM, you can find it on the website under the resources table. So if you want to deploy it on your machine, you can just download it from there and use it on VMware or VirtualBox or any virtualization software. All right, so let's continue now. Second step is to go inside the terminal of host H1. So right click on H1 terminal and then verify the interface configuration. Want to make sure that there's some IP addresses there and the interface name as we did in the previous lab. So we have this H1 H0 and we have the IP address. And note here how also the way we develop those labs is that for the MAC address, we use the convention of all zeros followed by the host number. So here, this is zeros followed by 1, and then for H2 is going to be zeros, 2, and so on and so forth. All right, now we're going to start first by going to the programming environment, compile, and then push this program, but we're not modify the program. It's already there. It's already written for us. So let's start by launching the Linux terminal from the desktop here. And then type in code P4 labs, and then lab 7. Okay. So now we started the Visual Studio Code, and we can see here we already have a program. The basic is already calling all the pipeline. We're instantiating this main here. And if we go to ingress, we can see that there's already some implementation written here. And also for the parser, it's already there. So all we have to do is just basically compile this program. P4C, basic.p4. And we have here a basic.json, right? That's the output of the compiler. Next step, as usual, once we compile, we have to push that output of the compiler, which defines the data plane, to our switch. So basic.json S1. And the password, again, is password here. Okay. Now, we can verify the configuration that this specific file was pushed to the switch. We have to go to mini edit, right? And then go inside the terminal of the P4 switch. Right click and then terminal. Then confirm that the file is there So ls, we have basic.json. And then, as usual, we want to make sure that the interfaces are there. So we type in ifconfig. And as you can see, we have those three interfaces. And the next step is to start the daemon. And so far, what we were doing, I'm going a little bit fast on them because that's exactly what we did in the previous lab. So we just compiled, push, and now starting the daemon. Simple switch -i 0 at s1 -eth 0 -i1 at s1 eth1 and 2 at s1 eth2. We're going to enable logging. And then give the input, which is the compiled data plane here, basic.json, and run it in the background by using the end character. Now we're gonna start by looking at the simple switch CLI. First, I will press enter just to get the terminal back. And now instead of calling this tool and sending as its input some file that was already created, we'll assume that we're gonna do everything from scratch inside the tool. So what we're gonna do is we're gonna start by typing in the tool name, which is simple switch underscore CLI. And because we are running it locally inside our switch S1, so it automatically detected that we have a switch daemon that is running, and it connected there. It obtained the JSON, which defines this data plane. And now we can basically issue the runtime commands so that we manipulate the tables at runtime. Okay, now there are some parameters that you can supply for this command, especially if you decide to have this control plane to be centralized, like in a controller in SDN. But then all you have to do is give the port number that the switch is listening on. And this way you can basically manage multiple switches as well. Okay. Now, the first thing we're gonna do, which is super helpful, is just type in the question mark here. And this is gonna show us the available commands. So there's some commands here that you can see for action profiles. First, you have counters. Those are some stateful elements that you would use in a P4 program. You have some multicasting you can modify here. But most importantly, at least for now, we have the table commands. So we have table add. This is for adding an entry. We have table clear, delete, dump, and many other commands that you can use to manipulate that table. Okay. Another thing we have to mention here is that we talked a little bit, we've seen multicast and other stuff. This tool allows you, or basically any runtime tool allows you to do a configuration for the traffic manager. And this was the non-programmable element, which was in the middle of the pipeline, right? So for example, creating multicast groups or doing some complex stuff like setting the queue size, all of these are done here in this tool, right? For example, set queue depth, set queue rate, and so on. So for now, we're just gonna be looking at the table commands so that we know maybe a few other commands, but we're gonna be focusing mostly on tables and not on the other objects. Also, I should mention that tab here is super important. It will allow you to autocomplete. And you can always get a help for a given command by typing in help followed by the command name. So for example, I want to see the syntax of the table dump. I can type in help table dump. And this is going to tell me that this command will display the entries in a match table. And the syntax is table dump followed by the table name. Okay. You can do also So you can issue some commands to display information about the ports. So for instance, if we type in show underscore ports, it will tell us that port 0 on your switch is mapped to S188H0, port 1 to S188H1, port 2 to S188H2. They are all up, so we know that they are up and running. And you can see here that this is exactly what we decided when we started the simple switch target. We said that 0 at S188H0 and 1 is at S188H1 and so on. Okay, so here you can see all the interfaces and ports and make sure they are up. Next, you can also see what are the available tables in your program. And this is important because let me first just enlarge a little bit this window so that we try to show as much as possible in one line. Show tables is important because a lot of times you have like a complex program that has a lot of tables. You might be using a program someone else did, and you want to see what are the available tables here. So, if you don't want to go over the code and open each and every file and try to trace what is happening, it's just easy to just use show tables. It will tell you that we have IPv4 host, part of the my ingress block. We have IPv4 LPM, part of also my ingress block. This is what we created in the previous lab. And it's going to tell us some more information. So you can see here MK, this is the match key, is IPv4.destination address. And the first one, the IPv4 host, uses exact matching, and the LPM uses the LPM matching. Okay. You can also see the available actions. So show actions. There's an underscore between them. And you can see we have two actions. We have a drop action in my ingress. It doesn't have any parameter. And we have the forward action, which is also inside my egress, but this one has destination address, which is 48 bits. And we have the port number, which is 9 bits. This is the port on the switch, right? Port 1, port 2, port 3, and so on. And also, you can display some information about the switch as a whole. So you can say switch info, and this is going to tell us that this device has an ID of 0. The Thrift port that's used is 9090. So this is useful if you want to connect to multiple devices running on the same machine, so you know what are their ports. And you will see here some more information, which we will not go through, but basically these are related for logging and notifications. Specifically, this file we've seen when we started the simple switch target, right? There's a lot to explore in this tool. It depends on how detail you want to keep digging in it, right? We are just covering the basics, at least to help you get started by using P4. There's also a nice command here, which is called get time elapsed, and this is going to tell you for how long the switch has been running, right? And this is showing you the time in microseconds. So yeah, so we have here micro, milli, and then you have here the seconds. This is how long the switch has been up, and by up here we mean when we started the simple switch target. All right, so those are the generic ones. Now we're gonna see how we can actually go into details regarding tables and manipulate the entries there. So the first step here is to display some information about the tables. For example, we can use the command table info if you want to get information on a specific table. So table underscore info, and you give it the table name. It's very important here, try as much as possible to use the tab. This way you avoid any typos. And basically you can see here I typed in, or I pressed on tab, it showed me my ingress.ipv4 underscore. And the reason is both of my tables start with IPv4 underscore. So if I press tab again, it's going to show me you have host and you have LPM. So let's say host. And this is going to give me information about the specific table. You can also show the actions that are only for this table rather than showing all the action as we did before. So this is going to be here in step number 2. Table show actions, and then you give it the table name. In our case here, my ingress.ipv4 host. Okay. Now, this one is very useful when you want to see what are the available entries inside the table. You want to display everything inside it. You want to dump the table entries. And the command to do this is table_dump. And also you give it the table name, right? So at this point, you can see that table entries, there's nothing. And it's showing us that we have a default entry, which is the drop, right? So it's only telling us that we have one default entry. There's no entries. If you have entries, you would see them under this table entries header here. And sometimes it's useful when you have large tables. You want to make sure that, let's say you have a plenty of rules that you pushed and you want to make sure that all of them are there. You don't want to go over each of them one by one. You can just display how many entries you have in your table so far. So if you type in table_num entries and then the table name, it's going to tell us here at this point we have 0 entries. We didn't push anything yet to it. Okay. Now we're gonna move to how we can add entries. So there is a command called table add. If you want to see how it looks like, what is the syntax? So we're just gonna use help, then table_add. And this is telling us that this command is used to add entry to a match table. The syntax is as follows. So table add, then you start with the table name, space, you have the action name and the match fields, right? Now here you would see there is like a equal greater than sign, which is like an arrow. Basically, this is used to separate whatever you have before for the match fields and the action parameters. Okay. And optionally, you can provide a priority, but we will not go over that in this lab. Now we'll see an example how we are actually adding an entry, and you'll see how it's mapped to this syntax definition that we see here. Okay, so let us try to add an entry to the IPv4 host table. So we'll start by, so now I'm in step number 2 here. So we'll start with table_add, and then we give it the table name. Remember to always write the whole name. It means that including the block where this table is. So in our case, it's in my ingress. So my ingress.ipv4 host, that's the table name. So all of this here correspond to the table name in the syntax. And then we have the action name. So we want to forward traffic for a given, let's say, IP address. So I will say that whenever we have a match on this IP that I'm going to write in this command, I want to execute the forward action. And also for the actions, we have to specify the whole name, including the control block name. So my ingress.forward. This is for the action name. Next, we have the match fields. So what is the value that I want to add to my table, which is going to be the key in our table, right? We know that we are matching on the destination IP. That's what we did in the previous lab. So here we have to type in some IP address. And remember, we are working with the host table. It means that this is an exact matching. So I can't write here /24 or /8 or anything like that. I will just write the IP address exactly as it is. So here we are saying we are adding an entry for the IP address 30.0.0.1. So these are the match fields. Now, once we have a match, right, and we executed this action, which is forward, what are the parameters that I want to pass to this action? And I will just move very quickly to the P4 code, just so that you understand what we're doing here. in the ingress.before, this is where we are creating the table and the actions, right? And in this command here, we are saying that we are adding to IPv4 host, right? So it means that for this table, okay, specifically for the action forward, right? And the match key, which this IPv4 host here is 30.0.0.1. Now, if we have a match here and the forward is executed, we want to pass some parameters. And those that you see here, the set of 0, 3, and then 2, these are what you pass here as parameter to the action. So first we have the MAC address. This is it, 0000000000 and 03. And then for the port number, this is going to be 2. If you had here more parameters, then you can keep writing here what parameters that you want. Okay, so always read it in a way that you are adding for this specific value for the key. And once you have a match, you want to execute this specific action. And for this action, you are specifying these parameters. All right, so let's go back and finish this command. So I'm going to write here 0, 0, 4. Okay. And by the way, you can just write 3, but here just to make it easy to understand what we are doing, we are typing in the whole thing, right? And then, so this is for destination address, and then for the port, this is going to be port number 2. And once we press on enter, you can see that we got an output similar to the one that I was describing in the previous lab. So essentially, in the file that we've been populating our tables with in the previous labs, all they contain is a sequence of table add commands such as this one, right? So if you put these in a file, you can pass a batch of these commands, all of them to the simple switch CLI, and therefore all of them will be executed and the entries will be inserted to your table. Okay. Now that we added one entry, we can reissue the table dump and see if it recognized that there's a new entry there. So table dump, and then my ingress.ipv4 host. And you can see that now we have an entry 0. The match key is destination address, exact, and this is actually the value that we added, which is 30.0.0.1, but it's represented here in hex. And for the action to be executed, it's forward, and the parameters are 03. So this is like a summarized version of what we wrote here, and then 02 for the port number. Okay. And now if we go back and also type in the previous command that we used, the table num entries, my ingress.ipv4 host, you can verify that it's incremented by 1. Now, we can also display a certain entry by using is match key. And this is very, very important because sometimes you have a lot of entries in a table and you want to see if a specific key exists there. So you can do so. You can type in this step 5 command here. So table dump entry from key. The table name, so my ingress.ipv4 host, and then the IP address or the key that you are using. Here in our case, this is, and you have to type it here in hexadecimal, right? So 1E000001 means the IP address 30001. And it's telling us that there is an entry for this key. Its number is 0, and this is the action to be executed for this key and the parameters for this action. Also, you can dump an entry by using the entry handle, which is these zeros that we've been seeing here. And this is like just a counter that starts from 0 and keep incrementing when you add more and more entries, right? So if you know that a certain a certain entry in your table has this specific entry number, you can also display information by using that number. And the way to do it is just table dump entry, the table name, and then you give it the entry handle. Here it's 0. And it's going to show us the same output, basically showing this match key, right? Also, it's important, especially if you are creating some logic on the control plane and you are modifying some entries in the data plane, you might want to modify sometimes some entry that's already there. And you can do so by using the table_modify. So table_modify, we can always type in help table modify to see the syntax. But it's super easy. It's very similar to the one that we used before, the table add. So you start with table modify, and then you write the table name. So my ingress.ipv4 host, and then the action. And here you have 0. This 0 here represents the handle. So this is the number that we were using in the previous command, right? So we're saying that we want to modify the entry numbered 0, and now the new action parameters would be 0, 0, 0, 0, 0, 0, 0, 0, and 0, 5, right? So remember it was 0, 3 before. The port was 0, 2. Now we're going to put it to 5. So modifying entry 0 for this exact match table. And then we can reissue the same command to make sure. So I will use the up arrow. And you can see that now for this specific entry, the action parameters are 5 and 5, basically what we wrote here. Okay. So this is how you can add and manipulate an entry for an exact table. So how can we do it for an LPM table? It's also super easy. All we have to do is first specify the table name, that's LPM. And then when we write the key, we have to specify / followed by a number, right? Typically, this would represent like a network. So for example, 20.0.0.0/8. All you have to do is write that here when you use the table add command. So let us try this now. Table add, my ingress, but now it's not IPv4 host, it's IPv4 LPM, because we are using the one with LPM matching. And then we will use the forward action. The match here would be 20.0.0.0/8. So this is the part here that is new. We are adding an address, and we are using the /8 to represent that this is the LPM key. And the action parameters, as usual, we use this arrow here to separate them. 0, 0, 0, and then 0, 0, and then 0, 2. And our output port would be 1. Okay, you can see now that the match key is showing that it's LPM, right? And this is for the IPv4 LPM table. Okay, and again, here we are seeing this 1.4. This is because it's in hex, but if you convert it to decimal, this should be 20, right? And then you can always delete a table entry. So you have a certain entry there, you want to delete it. So table delete my ingress dot IPv4_LPM. So we are specifying which table we want to delete the entry from, and then we specify the entry handle. Again, this is the index here for this entry, right? So we have 0. So we are removing this specific entry from our table. Another also very useful command is to clear a table. Sometimes you have a lot of entries there, and you just want to reset everything and start from scratch. So you can use table clear. This is going to remove all the entries from the table. So this is now here in step number 3. So table_clear, and you give it as a parameter here the table name, so IPv4 underscore LPM. And then we can verify by using the table num entries. And then the table name, which is IPv4 LPM. And we can see now it's 0 because we cleared that table. So this is a short lab that contains the basic commands that you would use for manipulating those match action tables. So as we discussed before, if you use the question mark, there is much more. We didn't cover the advanced parts because we didn't discuss yet what is multicast or counter or register and those stuff. We just saw the important ones that we use with tables, at least just to be able to populate the table and make sure that you have some entries that the data plane will use as the packet enters to your switch. But obviously there's a lot to explore here, and hopefully in the upcoming lab series we're gonna discuss like the advanced part of what you can do in the data plane, and there we're gonna show both what you would write in the data plane program and then how you can use this tool for handling whatever advanced feature that you use in the data plane. That's it, Dr. Jorge, if there's questions.
Yeah, thank you, Elie. There are two questions. The first one is, have you considered adding tabs to the mini edit to test things like what it was discussed by June?
So there's here like there's a challenge here if we want to talk about tapping. We know that the switches, the software switches, they have the port mirroring, or they have a duplication of packets from one port to another, but these are not good for applications for example, that are in network, because you would lose some timing information and you will get packet reordering and other stuff as well. Tapping, it might not be entirely possible here, and the reason is you might be able to do it, but then you would create kind of like a dummy interface in the middle and try to do that manually. I haven't done that before. I don't know if it's possible. I'm not sure if it's possible, but tapping in an emulated environment, especially with BMV2, for example, won't make too much sense, and because the timing information that you get from the switch is not granular. So it might be useful a little bit for like initial tests, but if you are planning to do something that really leverages the power of those programmable switches, you want to go to the hardware for timing measurements. Here you can always have like TCP dump and redirect the traffic to maybe some other interface. That is possible, but tap that will preserve the packets as they are, I haven't tried that, and again, I don't think that doing that on a software switch will be very, very relevant because of the timing information that is lost.
The second question is port number 5 just for an example? I don't see a port 5 on the labs before switch, so you use a port 5, yes.
Yeah, definitely. That's just like an example for the modify. Basically, it will accept it. It's not gonna complain about it. But here we have only in the topology here we have 3 ports, 0, 1, and 2. This tool didn't complain if you use a value of a port because it doesn't know exactly that this is a port, right? For this tool, this is just like a value that is 9 bits, and that's why it is it's just accepting it. But yeah, does it make sense in our example because there's no port 5? That's definitely true.
A new question. Is there a command to duplicate packet without being multicast?
So there might be, I can check here. There is something called mirroring that you can configure. And basically you would use that, all of this from the control plane. And this means that you're gonna be mirroring packet from one port to another. Now, if you're talking about duplicating packets from the data plane, this is like a whole different concept. There's what they call cloning and recirculation, but those are a little bit advanced. We didn't touch upon in this lab series. And you have always multicast here to create the groups and to associate nodes with the groups as well.
Right. Let's see if there's any other questions.
There's one comment I can add as well, since we have some time. So what we are doing now is using the simple switch CLI, right? And this is communicating with the target through Thrift so that you issue all these commands. But it's always possible to have your own, for example, Python program. If you decide you want to make an application on the control plane that is dynamically maybe pushing those entries or updating entries, you can create a Python program. And from there, you can import the library. There's like few things you can write in the Python program. You will instantiate an object, you will connect to the Thrift server, and there you can basically issue any of these commands that we are seeing here programmatically from a program. This way you can automate things if you are interested in doing so.
There is a question or a comment from Chris. Elie, I don't know if you prefer to read, it's a long one, or I can read for you.
Yeah, I can see it now. So in the output of help table add, it shows match fields, arrow, action parameters. I can see how the action parameters map onto the IPv4 action forward args. Can you explain how it knows that match fields is a destination IP versus some other thing that you want? Yeah, that's a very good question. The way this tool knows, this is what happens. So I will exit from it and then run it again. What you can see is it's saying that it's obtaining the JSON from the switch. And this JSON basically is, your data plane. And if you try to open that file, which is basic JSON, you will see that it contains all the necessary information. I think one of those information is the names that you are using there, right? And so this is how, when you use the auto-completion, for instance, in that tool, it knows exactly what are those names are, okay? Yeah, you can explore here, but basically this is like a whole representation of your data plane. So the more complex your P4 program is, the larger this file is, and you will see more information about what you wrote here. But this is specific to BMV2. I have to mention that. We know, for example, with Intel Tofino, the output is not JSON, right? And it's proprietary, so it's like .bin. It's a binary output, so you can't actually see any of those. But there you also have like some APIs that you can use to manipulate the tables. All I'm saying is for this tool, it's taking this JSON because that's how the data plane is expressed when you compile for a BMV2 target. Yeah, no problem.
All right. I don't see any additional question. Well, thank you very much, Elie, for this last session. And this was the last session of this workshop. So I want to remind everyone, first, I want to thank you all for coming to this workshop. All the material that was used in this workshop will be in this website, including the video. For example, the recording of day number 1 is in the website. The day number 2 is going to be within the next 1 or 2 days. It's going to be here, including the PowerPoint slide of the presentation that we had today. In closing, Jason, I don't know if you want to add anything.
Nothing to add, just that this has been a really great workshop, and we hope that everybody was able to get some good experience in learning about P4 and related technologies. And the team at University of South Carolina is an excellent resource if anybody does have questions in the future, or if anybody does want to spin up some of the training instances to pass these lessons on to anybody else at your campus that may benefit from it, not only for the P4 topics, but for other cyber infrastructure topics as well. And we will be announcing another workshop pretty soon in April that's going to be focusing on other CI engineering things. And we will make sure to announce via the same channels that we did for this workshop.
Right, thank you, Jason. To conclude, I want to, again, I said this at the beginning, and we will be organizing additional workshops also on P4, the continuation of what we presented here. So we use intro to P4, so we will be building more advanced material, and we will be disseminating this. Finally, I want to ask you to please take a few minutes. You will be receiving an email with the survey. Your input, the feedback is very important to us. It helps us improve the workshop. You will be receiving that email tomorrow. So I want to thank you all again. Thank you for the interest on this workshop, and have a good rest of the day.